Good morning. Thank you for your patience. You do know it's a challenging day today, so we're just waiting for a few more people to come in, and then we will start. And thank you to those who braved the elements to be here today. Thank you. We are very privileged to have, let me put on in the last 2 years, I have to use this now. I keep on losing it though. So, Ms. Jolene Jacobs, who is the top 10 finalist of Mark May Famous Talent Competition, which was hosted by Emo Adams. I'm sure, especially the young people, you will know about Emo Adams. And she's going to just give us a nice welcome musical item. So, Jolene, over to you.
It's over. Morning, morning, everybody.
Jolene, do you have more? Later, she says. I think that was quite appropriate, especially given our turbulent times. I know the Vice-Chancellor of CPUT always speaks about VUCA, and I think we mustn't lose hope. We must keep to our dreams, but even more importantly, we should have action. The only way to realize our dreams is to put it into action. So I'm not going to be doing the official welcome. We have a very, very special person at CPUT, our leader, and he's the Vice-Chancellor, Professor Dr. Chris Inhlapu. And if I can please ask Prof to come up to welcome you officially. Thank you.
Thank you, Jackie, for the very kind introduction. I must say I am moved by the rendition. It's really appropriate. And thank you very much, Jolene. You hit the notes well. I must say that we must apologize because we're targeting so many students. But unfortunately, we know the situation in our province because we want more learners into STEM. We want more women, female students into STEM to deal with some of the stereotypes that are still persisting in the system, that science is only for a selected group of people, particularly male, and of course female students are not actually part and parcel of that. Program Director, Ms. Jackie Skeppers, members of the Department of Science and Innovation here present, members of the Department of Higher Education and Training under the program of UCDG, and of course, members of the National Research Foundation, or I must actually say my ex-employers, particularly SASTA. I come a long way with SASTA, and I'm happy that you are hosting this thing here at CPUT. I heard my colleague, Dr. Bernard Ntambeleni, was actually saying the Science Week is in Venda. Well, they were having another version in Venda, in Toyando, University of Venda. But I said we also have. And I know it's not actually the last. We have had some version under Dr. Jabu Nukeri before. And we have always delivered as an institution. And a special thanks to Ms. Jackie Skeppers, the director, Professor Lynn Reddy, and the entire team. And of course, Mr. Maseko. I think I will be remiss of my duty if I don't acknowledge you for the work well done. All senior management and all CPUT staff present here, members of CPUT executive present here, student at the Cape Peninsula University of Technology, program director. If I was at a different platform, I will invoke the principle of de minimis non curat lex, or I will invoke the principle of in dubio pro reo. That means that if I didn't cover anybody, which is possible in conferences or symposium of this magnitude, that I will be forgiven because it is so small. And as they say in law, you cannot prosecute a person if really the dispute is actually very small. So in this particular case, I will invoke those particular principles to say, if I omitted your name, you are also covered in the protocol that I've actually cited. Program Director, with your gracious permission, let me stand on those protocols you so kindly established. Firstly, greeting to all our guests from near and far. Molweni mawethu. Molweni. Ninjani. Akukho nto? Thank you very much. Good morning, ladies and gentlemen. Good morning. Goeiemôre, dames en heren. Hoe gaan dit? Goed. Good. Let me start by saying a few words about my own background. As I've been introduced, I'm Chris Nhlapu. I'm a chemist by profession. I am also an avid supporter and scholar of science education, especially chemistry education. When I started my career, I was very interested in how chemistry should and must be taught. And I was actually one person who used to work with ESCOM in particular around running Science Expo, because I spent so many times in the lab. My life was in the lab. I was a senior lab assistant, I think for more than 15 years. So I used to literally live in the lab, mix chemicals and everything else. So the teaching of chemistry in particular was very, very close to my heart, up until I ventured into something else, which was catalysis now and no more science education. So early in my career, I managed ESCOM Expo for Young Scientists, which is an exposition or science fair. I realized early in life that doing what is right never goes out of fashion. As Oriana Fallaci will say, there are 3 points of view to everything: mine, yours, and the truth. Some people say, but this is too simple to be right. And the answer is, that is because it is. Scientific truth, science realism, and of course the principle of scientific universalism, which is an idea that everyone can do science, regardless of race, nationality, gender, or any other differences, and that everyone's scientific claims should be scrutinized equally. And we used to say that in terms of this scientific truth that you're talking about, if x is equal to 5, x is equal to 5. You can actually pronounce it in any other way, but we will actually see that we are talking about the same value. The values scientists should have is curiosity, honesty in recording and validation of data, flexibility, persistence, transparency. We can go on and on. But I must say this morning, my role at the Cape Peninsula University of Technology is to drive what we call Vision 2030, or what other people will actually say is a decadal plan for the institution. Others will actually say it is one smart CPUT, which is a construct with 2 dimensions, or a concept with 2 dimensions, that of smartness and that of oneness. It combines both technological astute as well as human centricity, because we wanted to be one, just one community at CPUT. One smart university is both a physical and a visual environment led by humans coming together to create a more humane, immersive, interactive, and automated experience for students, staff, faculty, researchers, and the stakeholders of university. The Vice-Chancellor alone will never achieve this audacious vision. I'm counting on you. However, the STEMI symposium that we are having today is a step in the right direction, and that is our contribution to NSW, or National Science Week. And as I've indicated earlier, that it is important that we have every shoulder on the wheel, because the Vice-Chancellor alone will never achieve this audacious goal. As I always quote, and when we started drafting this audacious vision, I said, elkeen moet sy plek doen, dan alles sal regkom. I quoted Jan Brandt. And I also said, as elkeen voor sy eie deur vee, sal die straat skoon wees. So you do your little piece wherever you are. If we aggregated those particular pieces together, we'll be able to cover everything, every square inch of the institution. If you are in the residences, if you are at the gate of this institution, do your best. And of course, we'll aggregate those particular pieces together. We will be able to go somewhere as an institution. That's why sometimes when I go out of the gate and they are not searching my car, I stop and I open the boot from the inside. Come and search me. Because it's important that everyone is doing his or her best. And we'll take this magnificent institution to a different level. As I always say, we are not doing that for ourselves, but we are doing it for the next generation, because this is a public institution. And CPUT does not belong to us who are here now, but rather we are the guardians of the institution for the future generations. We will leave behind a legacy far beyond our time here, far beyond our imagination. Program Director, Ms. Jackie Skeppros, it is a great honor and privilege to open this auspicious Vice-Chancellor's STEM Symposium, themed, or aptly themed, Transforming Life Through Evidence-Based Science. This is part of celebration of the National Science Week in partnership with the Department of Science and Innovation, in partnership with the Department of Higher Education through UCDG. Recently, the DVC Research, Technology and Innovation and Partnerships, Dr. Pau and I twice visited the University of Paris, the Pantheon. I must say, we were moved to tears at how the French acknowledge the memory of great Frenchmen, especially the scientists. We were moved at how great nations honor these great men and women, especially scientists. And as they say in Latin, os grands hommes la parte reconnaissante. We were moved to the extent that we took train. For the second time, we took train, because this is a concept that we're actually having right outside here in the Dome of Remembrance. We are busy with that particular project. We'll be launching it soon, because that is going to be a space where we pay homage to our great scientists out of this institution. We want to immortalize them right here in front of us. We went straight into the crypt, and in the crypt slumbers great patriots and heroes and heroines of France. And we took some time to visit Jean-Jacques Rousseau. Rousseau is there. Voltaire is there, immortalized there. Marie Curie is immortalized there, together with her husband. In fact, they are in the same area. Both Pierre and Marie Curie, or Marie Skłodowska, they are both there. And at one point, I know that people are saying, but this lady was actually in radiation chemistry. So her body is still radiating, be careful. don't go closer to this particular grave because radiation, polonium, is still coming out of her because she was actually deep into radiation chemistry. And we said, Dr. Pao, we said, we are going in there. Because these are people who grow. These are people who demonstrated that a human being is without a limit. You can actually grow and be embraced by everybody in the world. And I can tell you that the Pantheon is always full because of the contribution of what a human being can actually do. And I think platforms like this are meant to encourage our people that there is no limit. You can be anything that you wanted to be. And you can actually as big as you wanted to be. And of course, what will be left, it will be for us to create that particular environment and for us to honor you. And some of the things that people enjoy are simple and popular demonstrations of the work, for example, of Jean Bernard Leon Foucault, who is credited for many experiments in astronomy. That, for example, today we know that the Earth goes around on its axis, that the Earth rotates around the sun and at what speed. But for the young ones, if you like to see the Earth rotate, in front they'll say, go to the Pantheon and just observe the Foucault pendulum experience, because the Foucault pendulum experience is there. We all know what is a pendulum. Program Director, the National Science Week is an annually celebrated initiative of the Department of Science and Innovation, a celebration of science, technology, engineering, mathematics, and innovation, STEMI. I'm aware that CPUT was involved in various stakeholder STEMI activities. And I'm actually happy about this because as an institution, we also have a committee from the Vice-Chancellor that we are running these activities. I'm aware of the STEM Roadshow in Central Karoo that took place from the 31st of July to the 3rd of August. And well done to the project teams that consist of students and staff. I'm aware of the STEM Expo competition that took place yesterday in collaboration with Fundani, Center for Higher Education Development. Well, of course, today we are having the Vice-Chancellor's STEM Symposium as a contribution to the National Science Week. I am also aware that tomorrow we'll have the second chance matric rewrite learners here, also concluding the celebration. Because we have taken upon ourselves that we must create that reservoir for people who fail matric, who did not perform well because they did not do well in mathematics. Bring them back into the system. Ensure that they can actually deal with what is called, I don't want to use killer subject because sometimes people are saying math is a killer subject. It is not. And we are demystifying and debunking that particular myth here. And we have a number of people who came from science rewrite, who graduated, some at master's level. That's the contribution that this institution must make to the society, to the country, and of course, to the creation of the new generation of academics. It is one of the many initiatives conducted under the science engagement strategy of the country. We seek to develop a society that is knowledgeable about science, able to form independent opinion about science, and scientifically literate. This is a countrywide initiative to celebrate science involving various stakeholders and or role players conducting science-based activities. It will entrench the concept of science as a systematic study of the structure and behavior of a physical and natural world through observation, experimentation, and the testing of theories against the evidence obtained. It will perhaps, I think, also help us to deal with the growing anti-science and pseudoscience. Of late, we have seen in Europe, in the North America, and indeed in our continent, of growing anti-scientism. Anti-scientism is escalating and is going global. The rejection of mainstream science is becoming a key feature of political rights almost everywhere. Politics is an observational, not an experimental science. Sometimes people talk about political science, but please note that it's observational and not experimental science. We are living indeed, Program Director, as you said earlier, in times of volatility, uncertainty, complexity, and ambiguity, or the so-called VUCA world. Dames en heren, ons leef in 'n snel veranderende, uitdagende wêreld, waarin veranderende die enigste konstant geword het. Ons toekoms, ons kinders se toekoms, sal nie meer dieselfde wees. We are all addicted to distraction, one reason or the other. A thoughtful take on distraction is instructive. Please note, an addiction to distraction is the death of creative production. So we should move away from addiction to distraction. I hope you'll enjoy the event and the exciting speakers to come. Let me thank you profusely for attending this event. Humans are threatening their own existence and that of other species by using up world resources. This planet does not belong only to us. We are in ecosystem. There are other species that we must actually ensure we live in harmony. People are saying that men are becoming a plague to the world. And it's very important that we manage the relationship between man and environment judiciously, because man's survival is dependent on the environment. And Sir David Attenborough said, I quote, "We live our comfortable life in the shadow of a disaster of our own making. That disaster is being brought about by the very things that allow us to live our comfort lives," close quote. So this institution, we are creating futures. And as we always say, the future starts today. What is today was once the future, and it will soon be the past. And it's very important to the young one who are aspiring to get into the field of science, that you know that your future is not in the future, but it starts today. Because very soon, this future will be the past. It will be history. And that's the reason for studying history. Ladies and gentlemen, in conclusion, talking about this future thing, which is very close to us, if you look at all our logos and our advert, we have creation of the future. I always like to quote Anna Korenko, who normally goes by the pen name Anna Akhmatova, when she's actually talking about the whole aspect of the future. She said, the future ripens in the past and rots in the future. The future ripens in the past and rots in the future. So that's exactly why I explained earlier that your future starts today. Ladies and gentlemen, enkosi mawethu ndiyabulela. Makube kuhle. Kube mhlophe. Kukhanye. Enkosi. Thank you very much.
Well, all I can say is wow. I think that has definitely set the tone. Thank you, Prof. Schlapo, for that inspirational and motivational rendition, and also framing the work that lies ahead for us. So I must say that I like your comment about we are doing this for the future generation, and also your reference to the Dome of Remembrance, because I've always believed that to go forward, we need to look back. We need to celebrate what is good, what is excellent, and perhaps not focus too much on what is not so good. And especially to the students today present, I see many, many of you. Some of you I know very well. I hope you've taken heed of those words, that you are making history as you're sitting here today. I just wanted to also mention that during the road show to the Central Karoo, it was -3 degrees there, with snow-topped mountains. It was quite challenging for some of the staff and students who were not used to the cold, but we kept warm. There were lots of hugs, and we were well received at all the schools. We did the roadshow in collaboration with GCIS, Government Communication and Information Systems. They've indicated they would like to do some more work with us and that they would be happy to be present at any of our events. And then also the Western provincial government, Central Karoo, local government. We're going to be talking next week about signing an agreement with them to collaborate on future projects in the STEM or STEM-I field in the future. So we've making good inroads, and many of the smaller towns, many of our students, many of the staff at the school, some of the principals studied at CPUT. So it was like going home, if I can call it that. And it also made us realize how widespread our footprint is within, well, we only went to the Western Cape province, but it just showed us that sometimes we forget how much impact we have in our communities. So thank you very much, Prof. Schlapo. And now I'm going to ask, I see Rida is here. I want to also make reference to the program. You will see on the insert that there's lots of information about National Science Week, and that the two sub-themes are energy, building sustainable electricity together, power of community, and then the second sub-theme is agriculture, advancing millets for a healthy diet. CPUT didn't buckle when SASTA said millets. Our staff from our faculties, and I must say thank you to the deans and HODs, they grabbed the topic and said, no, we will find something to do on the topic, because as you know, in the Western Cape, millets is not very common, but it is the grain of the future, and we therefore feel that we wanted to not just do one sub-theme, but to do both. So I'm going to also refer you to, from page 2 onwards, we have the bios of all the speakers here today. I'm not going to read their bios out because we are running a bit short of time, so I will just introduce them, but please have a look at the bios and network during the lunchtime as you see fit. So our first keynote speaker of the day is Mr. Rida Manuel, who is the coordinator of Energy Storage Graduate Program and Energy Storage Innovation Lab at the University of the Western Cape. And I do believe you are from CPUT, you are a graduate of CPUT. So you too, you at home now. So please come forward and share with us. I will open your presentation in the meantime. Thank you, Rita. I will do this very quickly. I think that's your one.
laser pointer?
I don't think. Okay, you can do it.
Okay, good. Good morning, everyone. Hope you're all well. So today I'll be speaking about building sustainable energy systems together as a community. So there's two parts to it. The first part is building sustainable energy systems. So it's sort of the switch from a fossil fuel-based system to a more renewable energy-based system, and why we need to make that shift, and how we can actually build these systems together as a community. Is it possible? So as you saw in the bio there, I'm the founder of Green New World, which is a company which focuses on building these low-cost and simple renewable energy systems and teaching it to the community to allow them to access the energy which is free. The energy of the sun is free. We just need the technologies to allow us to access that energy. And so we just like to start off with the problems that is currently being caused by the current system, fossil fuel-based system. Number one on the list is always load shedding. If I just say that word, everybody in the crowd cringes, they get a headache. So we always put that first to get that strong impact of the crowd. Load shedding, say the word. And and it's not only load shedding, it's also the electricity prices that keeps going up, the fuel prices. And this is the fossil fuel-based system. And we'll see that this price is going to just keep going up. The second one is global warming. Because of the current way we're producing energy, we're releasing tons of carbon dioxide into the atmosphere. It causes a layer around the earth, which traps the energy of the sun, causing the global temperature to rise, causing catastrophes around the world, fires, storms. And this is that famous graph. It shows that the Earth's temperature has remained constant and stable for hundreds of thousands of years, not thousands of years, hundreds of thousands of years. And then in 1950 to 1980s, we see the spike in temperature. And if we correlate this to the graph of a carbon dioxide layers throughout the centuries as well, we see the exact same pattern, that for hundreds of thousands of years it was constant. And then in 1950 you see the spike, which proves that it's as a result of us humans releasing the tons of carbon dioxide, as we see from this picture here, into the atmosphere. And this is why 97% of climate researchers today are convinced that the global warming and all the catastrophes being caused by it is definitely man-made. And it's sad to know that 80% of the world's activity is still being run on fossil fuels. And even sadder is that South Africa is one of the top producers of that carbon dioxide. So these are all the problems that are resulting as a result of us using fossil fuels to power the world. And the third one is something that's very close to my heart, is Africa without energy. And this is a picture we were shown in our master's course, which impacted me a lot. It shows that at night we see the entire world, most of the world is lit up. And if we look at Africa, we start to see that that's why it's called the dark continent. Because we see most of sub-Saharan Africa is completely dark. So we see North Africa is lit up and South Africa is lit up, but all of sub-Saharan Africa is dark. And that's why we're saying 90% of the people in sub-Saharan Africa, which amounts to about 600 million people, have no access to clean electricity and cooking fuels. And I feel that it's a responsibility of us as South Africans and North Africans who have access to the electricity, have access to the knowledge, have access to the resources to build the technologies to solve this problem. And the reason why I say this problem is something that's close to my heart is because for the past 10 years, I haven't only been studying engineering and working as an engineer, but also working a lot in the townships as well as in the villages of Africa. And I experienced this reality firsthand. I experienced exactly what it is to go into a village and the entire village is in complete darkness. And there's thousands of people walking down the road in complete darkness. And at the end of the day, you want to go take a shower and you turn on the tap and there's no water coming out of the tap because there's no electricity for the pumps to pump the water to get to the tap. Or sometimes you open the tap and there's just rust coming out. And it's becoming so hot and you want to put on a fan and the fan doesn't work because there's no electricity. And so just seeing this picture but the reality on the ground is much more stark. And so, and this is why I'm saying it is so close to my heart. And so we move on to the next slide to say that if we switch from this fossil fuel-based system to renewable energy, we can help solve these problems. By switching to renewable energy, we can have access to cheap electricity. As we're saying that fossil fuel-based electricity is about an average 3 Rand per kilowatt hour, but renewable energy is less than R1 per kilowatt hour. And this graph will just show the pattern of the price of renewable energy throughout the years. And this shows the price of fossil fuel-based electricity throughout the years. And in the year 2020, renewable energy electricity officially became cheaper than fossil fuel-based electricity. And fossil fuel-based electricity officially became more expensive than renewable energy electricity. So this relates to our electricity bills at the end of the month. If we basically switch to renewable energy, that electricity bill will drop, will be cut in a third. So not only that, renewable energy is clean electricity. None of that carbon oxide we saw in the first picture is being released to the production of electricity through renewable energy. And so we can reduce this carbon dioxide emissions, this temperature that's rising, the resulting catastrophes that's resulting, by simply switching to renewable energy. And the third one is that Africa in itself has an abundance of renewable energy resources. We are supposed to be at the forefront of developing renewable energy technologies. It's not only the renewable energy resource in that we have Africa has the best solar resource in the world, and South Africa has the best solar resource in the world, better than USA, better than the EU, but we also have the resources to build the technologies that can access this abundant resource. So we have an abundance of renewable energy resource, we have an abundance of resources to build the technologies that can allow us to access this renewable energy. So from looking at this, it is obvious that we're supposed to be at the forefront of developing these technologies and supplying all of Africa with this free energy that exists throughout the continent. The problem, however, is that currently to access renewable energy is so expensive. We want to have solar panels on our roof, but it costs 100,000 Rand. So no one can access this free energy. It's free energy, but the technology, we can't get the technology. And one of the main reasons is all of our technology is being imported. So we're importing all of our solar panels from China, or our wind turbines, or our batteries. And the reality is that we have all the resources to actually build these technologies. But what we are doing is we're giving all of our resources to other countries build the technologies, and then we give our money away. So we're giving our resources away, giving our money away. So we're giving all our power away. Are we actually solving the problem? This table here just shows that this is just an example of lithium-ion batteries. And the ingredients that goes into building the battery show that South Africa has 80% of the world's higher grade manganese. DRC has 66% of the cobalt reserves. Zimbabwe is the 5th largest producer in the world of the lithium. So we have all the resources, but I'm not sure what exactly the amount is, but it's in the billions what you spent last year alone in importing lithium-ion batteries. And we have all the resources. So that's the main problem. So we're using foreign expertise, foreign labor, whereas if we just have the knowledge, so I think that's the missing link. We have all the resources, we just need the knowledge to build the technology. And I think that is where we need to bridge that gap on educating the masses on what is possible, and can we actually get together as communities, which is the topic of this conversation, to actually build these technologies. And we will show you now that it is possible. And so we're saying that the solution is we need to make this renewable energy, the knowledge and the technologies, accessible to the people of Africa. And how are we going to do that? You see, the knowledge is very complex. It's found in textbooks, so very expensive textbooks, which is so big and so complex. If we open the text, we can't understand what we're reading. So what we try to do is, as Green New World, we try to take this complex knowledge and turn it into simple English, and then have these classes and speak to the general public in a way that they can understand it. And we not only convert this complex knowledge into simple knowledge so that people can understand. We also build simple technologies and teach people how to build these technologies, which allows them then to access this abundant resource that exists on the continent, that exists in South Africa. And then we hand over this knowledge to the people through classes. And so this is just a poster that I just put on here. This first part was just to show that the world requires about 18 terawatts to function, to operate. And it shows that the different renewable energy resources provides different amounts of terawatts which can be supplied to that overall amount. But bioenergy stands out here at providing 100 terawatts, which is enough to power the earth. But solar, on the other hand, stands out starkly in that shows that it can provide 120,000 terawatts. That is the potential of solar. And we're saying that if we can capture the earth's, if the earth can capture all the energy coming from the sun in just 1 hour, we can power the entire world's activities for an entire year. So this one statement is supposed to unlock the understanding in your mind of the potential of just solar on its own, let alone adding bioenergy, adding geothermal. And so we're saying that all we need is the different technologies to access this energy and convert it to the energy that the earth needs. But as we're saying, all of these technologies are so expensive and so complex to build. So this is our duty as Green New World. Make the knowledge simple and teach it to the people. Study these technologies and study the physics principles behind which it operates, and use that same physics principles to build simple technologies, cheaper technologies, which the general masses can build themselves. The communities can get together and build these technologies. And then we teach it at these classes. And so far, many people has been interested in this knowledge, which shows that people are they want to make this change. And as we said in the beginning, the technology is so expensive, but there is a different route. Through education of the masses, these schools and these communities can get together and build these simple technologies. And this is like at eco-villages, at schools, on farms, at my home. And there's so many people that are so interested and willing to make the shift. And as we go through this process, we want to build as many forms of technologies that access as many forms of renewable energy as possible, and integrate all these technologies together until we can get a constant and reliable supply of energy. Because the sun isn't always shining, and the wind isn't always blowing. It's not always bioenergy. But the chances are, if the sun isn't shining, perhaps the wind is blowing. And if the wind isn't blowing, the oceans and the rivers are flowing. If the oceans and the rivers aren't flowing, there's bioenergy. And if all of this isn't available, there's energy storage. And so when we start integrating all these technologies, we start to get this constant and reliable supply of energy. And our mission is to study all of these technologies and to build simpler, cheaper versions of it. Teach this to the people so that they can have access to this free energy that is widely available on the continent and the country. And so I like to call like the phases of building this what we call the Green New World. That's the vision. That's the ideal, to build the Green New World. That's why the company is called Green New World. It's the vision. We want to build this Green New World in Africa. And the first phase is what we're speaking about, building the system. So we build these low-cost renewable energy technologies, right? It accesses as many forms of renewable energy as possible. Integrate all of them into this one system. As we build them, we give over and hand over this knowledge to the people, to the general public. And as we build the system onto a farm, right? So this is the system that we built, and we're putting all our systems onto a farm. Eventually, what we want is a complete off-grid energy system that is on this farm. And this energy system must power other sustainable forms of living, such as sustainable farming. We can have hydroponics. We can have different forms of sustainable farming, and can power sustainable water systems. We can have rain capturing systems, pumping water from the ground, water purification systems, having our own source of clean water, having our own source of food that is organic and pesticide-free and chemical-free, our own form of housing, natural earth housing, And we integrate all of this system again, all together, integrated, to get this prototype green new world, an off-grid, sustainable village. A prototype to show the world, or to show South Africa, here's a working system. The possibility is there to shift from the old system or the current system to a new system that produces no greenhouse gases, that can provide you energy anytime you need it, that can give you clean water anytime you need it. And so as we're developing and living in the system and teaching the people, we're developing this group of scientists and engineers, young scientists and engineers, that is becoming empowered and inspired to create this change and make the shift. And as they become inspired and empowered, we tell them that this isn't the end. We need to now take the system into Africa and solve this last problem we spoke about, energy, Africa without energy. And as we move throughout Africa, through the villages, we go through the same process. We teach the people of Africa how to build these systems themselves, how to use the resources that is in their lands to build their own technologies, to solve their own problems. So the people of Africa becomes the workforce. We don't need to bring in other external workforce. We don't need to bring in foreign expertise. Now we're bringing in everything in-house, using our own resources to build our own technologies to solve our own problems. And this is how things become cheaper. Things become more affordable. You don't have to pay 100,000 to access the energy of the sun. And so, an example of this is like, I call the cheapest route in. You know, build the cheapest thing to allow you to access the energy of the sun. This is called the plastic bottle solar shower. It's basically waste to energy. We're using plastic bottles, right, to trap the energy of the sun. In the same way the carbon dioxide layer around the planet is trapping the energy, we use that same so the greenhouse effect. And we use then milk cartons, we put it inside there to absorb the energy of the sun. And as we absorb the energy of the sun, the water is fed via gravity into this panel and is in contact with the milk cartons, and the water inside this panel starts to heat up and therefore becomes less dense than the colder water, which is heavier in this container. As a result, the colder, heavier water wants to sink, and the warmer, lighter water wants to rise. So it sets up, because of this temperature difference, a natural cycle called the thermal siphon effect. You just leave it there. You don't have to do nothing. And you will see that the water starts to travel up this pipe here. It's as if it's going against gravity and it's being pumped into that container. And if you open this container, you can actually see the water being pumped in, even though there's no pumps. And when people see this, they can't understand what's happening. And we tell them, this is not magic. It's just science. This is the power of science. And I think this really makes science and physics extremely interesting, when you can actually use what you learned in school to build technologies that can actually solve problems. You build this thing, you get warm water at home, you're taking 70% off your electricity bill, because the geyser is taking 70% of your, so if your electricity bill is 1,000 rand, 700 rand is going towards the geyser. And you can then use that to bath with and put in a pool, warm water pool. And there's just a picture of showing the temperature there, almost 50 degrees. In about 2 hours, it's 50 degrees. Extremely comfortable to shower in. And then we connected it up to a few containers. And through this system, you can control how much water you're actually heating up, depending on how much sunlight there is. So the more sunlight there is, the more containers you can open up, and the more water you can heat. And if there's less water, you close up and you only heat up one container. And so because the water is already raised above, this is basically an outdoor shower. You just open the door, you step inside, and you take a shower. So we covered it up for the ladies and for so and because it's raised above the shower, it's gravity fed. There's no pumps involved, no elements involved. You just place this thing in the shower, in the sun, and you can take a shower. Whether in the deserts of Africa, in the jungles of Africa, you can put it anywhere. And obviously, if the people of Africa start to realize, hey, we can actually build solar panels out of waste, they will start cleaning up the streets themselves. They will start to view waste as a resource They will start to see, hey, there's a plastic bottle, let's go get it, we can build a solar panel. They will start cleaning up their own streets, they will start cleaning up Africa. And instead of this waste ending up in waste piles and on our streets will start to be cleaned up and be converted into technologies which is actually giving us the energy that we need in our daily lives. So the second one is a more higher tech version of it, but we're still using very cheap materials. The structure is made out of wood. There's an aluminium sheet at the back which is absorbing the energy of the sun, and then behind it is a styrofoam sheet which is acting as an insulator, preventing the heat from escaping. And this piping system then conducts that energy from the aluminium sheet to the water, and the same system is set up as the water sinks under gravity to the panel. The water in here heats up, becomes less dense and lighter than the colder, heavier water in that container, and the exact same cycle is set up. So the same system, you just put it in the sun and the water in here heats up. And with this system became so hot that these pipes started to melt. And we found that the water wasn't leaking out, it was steaming out, which means it's possible that we could have hit 100 degrees in the system. I mean, we built this in our yard, and we're hitting 100 degrees. All we did was apply the same physics principles that normal arm and a leg geyser would cost, and apply the exact same principles to build a simple technology. And so then we used that system, we piped it into the bathroom, so whenever we needed an off-grid or home water supply, open the window and pull the tap in, or for the water to wash the dishes with. And that was another shower we built in our yard, the shower there in free energy. So just two more and then we will be complete. So this was a system I built at UWC. So this is a green hydrogen educational kit, and I think this will be on display as well at one of the stands. Not this specific one. This one, I'm showing this one because this one was completely made in South Africa. Everything you see here, so how it works is that this is a column of water here, which represents a water source, right? And this water is being fed via gravity into an electrolyzer. And then we apply a current to the water from a solar panel. This is a light here, but if the system is placed in the sun, it will work even better. So the solar panels convert the energy of the sun into electricity, which is applied to the water. The water then splits into hydrogen and into oxygen. H2O splits into hydrogen, H, and into O. This membrane in the center, and the membrane itself was also made by the students at UWC, the chemistry students. So they made the catalyst that goes onto the membrane. Iridium oxide in here and platinum carbon on there. So the whole thing was made. I designed this whole thing on SolidWorks. Everything was made in-house, which proves to us that we can make the technologies ourselves. We don't have to spend billions on importing technologies and only allowing these technologies to be available to the super rich. And so what happens is it splits, and this membrane only allows the hydrogen to pass through. So it separates the hydrogen from the oxygen in the form of gas. And because it's less dense than the water, it starts to rise and it starts to build up there. So they have the hydrogen there. So that in essence is called green hydrogen. It is produced using green energy, using renewable energy. And once it builds up here, it starts to move into what's called the fuel cell. What the fuel cell does, it further splits it into the hydrogen, into protons and into electrons. Now this membrane here also only allows the protons to pass through. But the electrons also wants to pass through because of the potential difference. But it can't pass through. So we just put a wire there, which allows the electron to move through the wire, and it then powers the fan. And then it returns back to the proton and forms the hydrogen again. The oxygen that we produce meets with that same hydrogen and forms water again. So in essence what we did was, we split water and we put it back together again. And from that we got fuel and we got electricity. So this shows us the potential that if we can take the system and we have the ocean, which takes up, and the world is 70%. We don't have to use fresh water. We can use wastewater. We can use the water of the oceans. And we can have these solar farms next to it. Use a portion of the energy to desalinate the water, and then use the rest of the energy in these electrolyzers, which will split the water into hydrogen and into oxygen. That hydrogen is the green hydrogen. South Africa is supposed to be at the, and we will most likely be, if we wake up, at the head of this. Because the main ingredient that goes into, for example, the fuel cell is platinum. And we have the highest reserves of platinum in the world. So once again, we have all the resources to build all the technologies to solve all the problems in South Africa and in Africa. And what we want to do with the system is, we want to build these systems here at UWC and get it into schools and into high schools and into universities to make the future generations excited about the future and to inspire them to build these technologies and to inspire them to go to follow career paths which will eventually allow them to build these technologies. But it must be shown to them. It can't be just shown like this on slides. It must be this physical concept in front of them. This must be their projects. This must be the end of year projects. They must build these electrolyzers. They must build the fuel cells. They must build these solar panels. They must integrate the system. This is the future. And so we want to inspire them and motivate them for the future. Prepare them for this future. And this is the last project which we want to show is that with our students, and I think some of them are here today, is building this mobile UPS system. And this whole system, the whole structure, last week they built this whole structure themselves. They were taught how to cut, how to grind, how to weld, and put this whole system together. They designed this whole thing. This is their design from SolidWorks. It's going to be a mobile system, 5 kilowatt-hour system that acts as a if someone is working off-grid, there's no energy supply and they need to grind something, they can just plug it into this. There's power enough to use power tools. If you want to have power in your homes, it's movable. It's a mobile energy system. And so what we want to do is, so I'm training electrical and mechanical engineers how to build these systems, and eventually they must train the TVET colleges how to mass produce these systems, and eventually they can start their own businesses. So we're empowering to build renewable energy systems, to start their own businesses in this, and eventually, when they're done with the system, they just move on, design the next system, then teach the TVET colleges how to build it, we mass produce it, and this is how we can create this everlasting change and the shift to renewable energy. And just finally, I just want, you can go research this yourself, but a man by the name of Banker Roy, he started what's called the Barefoot College. And he went into India and he taught the poorest of the poor, exactly like we want to do, go into the villages. And he taught hundreds of women how to build solar panels, how to build solar cookers. The whole university was run by solar energy, built by solar panels, by women who had hardly any education. All the food, if you go there, is cooked via solar cookers. And these solar cookers was built by this woman who had little to no education. So this idea of educating the masses and educating the general public on how to build these technologies has already been shown. It's already proven that it's possible. So at Green New World, we have this vision, we have the plan, we have started building technologies already. Here is proof that it is possible. All we need is that backing. All we need is that support to take this to the next level, to create such change like this man has created throughout India and throughout other countries. This shows that it is possible, that we can access the energy which is widely available. We saw this image that Africa has the best solar resource in the world. South Africa has the best resource in the world. We just need to make the shift through mass education of the masses. And this shows that it is possible. And I hope you were inspired and enlightened and empowered to create this change and to stand with us and to support us and support the youth, because Green New World is not only also we like to inspire the school children, the youth, because like we said, we want to create this army of empowered and enlightened scientists and engineers, and they must be the ones who move through Africa and creates this everlasting change. I thank you.
Thank you very much, Rita Manuel, and especially to the young people here. I hope you heard the call for action and for a new kind of activism, and that is green activism. So many of you I know are involved in some green activities, which you will see next door, but I am really enthused. I'm going to start collecting my bottles now. And I'll be calling on you to show me how to do this. And I hope your door is open to some collaboration with some of our students when they go into the schools, because this is the kind of problem solving that is doable. You've given us the tools, you've shown us how it is done in other parts of the world. And yes, we must look into ourselves. We can do this, definitely. I agree with you. And you gave us some bleak facts, which I'm sure we've taken and absorbed. And remember that with every crisis, yes, we all complain about the energy crisis and the disruption to our lives, but this leads to many opportunities and a chance for us to look within our own resources and in our own partners that we have around us, so that we can solve our own problems. We're quite capable of that, as we heard from Rido. And these great opportunities for job creation, from what I can see. And I know in our Student Leadership Academy, we were talking about that. And I must say, many of the students I've met recently show great promise in thinking about how can we do this for ourselves? How can we solve problems for ourselves? So at CPUT, we do talk about quintuple partnership, helix partnerships, and therefore I would like to say, let's partner and let's see what we can do together. And thank you, Dr. Marco Donis, for introducing us to this dynamic a student and alumnus from CPUT, and now spreading his wings. We're really proud of you. Thank you so much. And talking about Dr. Marco Adonis, I think you are next. If you can come forward, please. I think Ridor deserves another big round of applause. Enjoy. I think it's going to come up like this. Is that yours?
That's me. Thank you. Good day, everybody. Good morning. I decided to title my presentation, Power to the People. So it does have quite a double meaning, and I was really trying to go for that. So power insofar as political power, but also the electrical power, all right? And let's just try and explore this concept insofar as how this relates to community and community power. At the end of the day, what really affects you and me is that if we walk into a room and we switch on that light, is that the light comes on. For you and me, when we want to make a cup of coffee and we have our kettle and we switch on that kettle, we want the kettle to boil the water. That's basically what we want when we start talking about energy. Electrical energy, we start talking about power. So what we find really in this whole landscape of energy, a whole landscape of electrical power, is a lot of buzzwords, a lot of keywords, and sometimes these keywords, they can be very confusing. They overpower us, saying all kind of different things, and we hear them constantly. You know, there's this different policy, there's this mandate, there's this direction. You know, stuff like net zero, green energy, just energy transition. You know, there's a lot to unpack there. There is a lot. What does all this mean for you and me? What does this really mean? Sustainable development, energy security, climate change mitigation, low carbon energy, and so forth. What does all of this mean? All right, let us just take a look at the stats that we find globally with regards to electricity. And let's just see if we can try and make some sense out of this. All right, if we just take a look at fossil and nuclear fuel as an energy source and its prevalence in the world currently. So this is stats of 2022. Coal still dominates the landscape. No matter which way we look at it, coal dominates at 36%. 36% of the world's economy is run on coal. Which are the countries that feature there? So China, the first country, let me just maybe explain to you, the first country we see there, and the second country, we'll see two countries at each technology. So the first country is just by bulk or capacity. The second country is the share of its national energy mix. So China is by far the largest coal energy, or energy which is produced from coal producer globally, all right? And then in terms of the energy mix, for a small country like Kosovo, it's about 94%. It basically runs on coal. All right. In terms of gas, natural gas, 22% of the world runs on natural gas. Which are the countries that feature there? The USA. By bulk or capacity, their economy is at least approximately 40% run on gas. And then Kuwait as well, with regards to its energy mix, it practically runs on gas. All right. Nuclear power, 9% of global electricity. USA there, once again, 30% of its economy is powered by nuclear power. France, in terms of its energy mix, over 60% of it is run by nuclear power. All right, so just to give you an idea just where we are currently with regards to where the world stands. Then in terms of South Africa, we just bring that a bit closer to home. Out of our total capacity, generation capacity of 52 gigawatts, over 80% of our economy is run on coal. All right. We don't really count nuclear as a fossil fuel, but yeah, we put that in there because it's a problem on another level. So just once again, just once you get the picture of just the scale of the electricity landscape, not only globally, but locally as well. All right. Let's take a look at renewables. The whole talk about renewables. So hydro energy still dominates worldwide in terms of a renewable source. 15% of the world runs on hydro. And basically, most of sub-Saharan Africa runs on hydro. Then China is the biggest bulk producer at 15%, and Paraguay, basically, its economy runs on hydro. Wind power, approximately 8%. China is the world's biggest contributor of wind power, all right? It seems strange, but it's only at 9%. All right, Denmark, its largest share, over 50% of its economy is powered by wind. All right, solar power, 4.5%. China, once again, dominates the world with regards to having solar power its economy at 4.7%. And Chile, its energy mix is 17% contributed by solar. All right, bioenergy, very small, 2.4%. China, once again, almost 2% of its economy is running on bio. And Brazil, about 9%. Last year, a record was reached with regards to total, or the combination of wind and solar, being at 12%. All right, so it is a positive move that we are moving in that direction of trying to get the world moving towards renewables. Okay, when we start talking about power to the people, just what power is coming to the people? What power is coming to you and me? So in terms of electrical power, all right, the dominant mechanism of how to distribute that power has generally been in two mechanisms, either centralized or decentralized. And centralized is the old way of doing things. I call it the power and control model. It's basically a way of governments to control that landscape, to control that bulk power which is delivered to their communities. All right. And it's also then saying that you as a community is dependent on me to produce that power for you. All right. Well, for us, closer to home, we can see that that has become a problem, all right, with regards to our new coal power station builds, Medupi and Kusile. Their costs have just escalated, all right. They've not been completed yet. They've not been fully connected to the grid yet, and their costs have skyrocketed. And it's me and you that is bearing that brunt. It's me and you that is paying for that. And this pales in comparison to, as we've heard from the previous speaker, that as the costs of fossil fuel generation, that cost per kilowatt hour is increasing, it sort of mismatches with the decreasing cost of renewables, solar and wind particularly. All right. Then also it's important for us to understand the impact or the difference in power produced at different times of the day. All right. And it's here where I maybe differ slightly from Mr. Manuel and his thinking with regards to the value of that power that is produced for us. Because power which is produced at the peak, which means when most of us is requesting from the grid power, that is the most valuable. Because if a utility, if a company can produce and deliver that power when the most of the people is asking for it, that is when you can then charge a premium on that, because you've got this supply-demand dynamic. All right. So obviously we got this issue with regards to renewables. They are not, it is not a dispatchable commodity, because the sun doesn't shine 24 hours a day. The wind doesn't blow 24 hours a day. Oh, we don't know when the wind blows. We're not able to control these large natural forces. So it is very difficult for us to switch this power station on, if it is run by solar, if it is run by wind, when this big demand comes. And we've got two big demands during the day. In the morning, about 6 to 8, and about the same time, 6 to 8 in the evening. So this is the premium time in your day. And it just so happens, if you just look at solar, it's not available at that time. Wind, well, we don't know when wind blows. All right, so we've got this issue of how to solve those two problems. And in that regard, we've always got to then think of a renewable system with some energy storage capacity. All right, so that those two become synonymous. You cannot talk about renewables without talking about energy storage. And this also then brings in its own challenges and its own problems, as we've heard previously, because now you're bringing in a different dynamic, all right? Because if it is batteries that you are using in energy storage, we don't have a battery manufacturing facility in the country. We are importing all our batteries. All right. So we are empowering, if we are going to be buying batteries, some external economy by paying them money to deliver the raw materials which we are shipping out and buying back at a premium. All right. So just to put this in context again with regards to what I would like to call using our local resource. So coal, as an example for China, the same for the USA, the same for Europe, and very similar for the Middle East with regards to gas and oil. They used their natural resource, all right, their bulk natural resource, which was coal, largely, to power and deliver their economies to the current state at which they are, which is, call it developed economies, as is mostly called in the literature. All right, so they've used coal, this dirty fuel, to power the economies to reach this developed state that they are right now. But now the world becomes very much talking about green and renewable. And the talk is that, no, you shouldn't be using your coal anymore. Yes, we know you've got coal, but you shouldn't be using it because it's dirty, because it contributes to this greenhouse gas emissions. But the problem becomes, for South Africa as an example, we've got 75% of our coal still under the ground. This is our cheap resource. Do we just leave it there and begin to use Western technologies which is imported to power our economy? Because if we just take a look at, as an example, the UK, who started this whole coal generation, all right, through the Industrial Revolution by powering steam locomotives and steam-powered engines. They started it because they had their own natural resource, which was coal. But they've basically depleted it all. So it's not an option for them unless they import it. But for us, with 75% of our resources still under the ground of this cheap resource, it becomes a different kind of question that we need to ask. Because for us and across Africa, where coal is also a vast resource, they are not using coal to power their economies as South Africa is. They're shipping that and exporting that to Europe. All right. And it's very interesting when we start thinking about this aspect, all right, really before this whole Ukraine conflict, the world was very talkative and very mindful about the green revolution and renewable energy. And you will notice now that post this conflict start, that talk is very quiet. That talk is very subdued, we could say. Because really, as an example, Europe, Germany in particular, who was talking very much about renewables and green energy, because their cheap supply of gas is now being cut off, basically, they have had to go back to their coal-fired power stations and begin to remove those mothballs and start them back up again, Because at the end of the day, like I'm telling you, when you walk into a room and you switch on that light switch, you want light. You don't really care whether it comes from renewables or from coal. You want it cheap and you want it available. You want it to be there. You want to be able to afford it and you want the light to be on. This is basically, people, this is what we want. We're not romantic about anything else. We are realists. I'm a realist. When I want a cup of coffee, I want to switch on that kettle and I want to know that the kettle will boil. I don't really care where it comes from, renewable power or coal. I want a cup of coffee, thank you. All right, so this is the kind of thing that we need to start thinking about. And I mean, this is what I try and inculcate in my students, and Mr. Manuel is one example of this in this class that I run with regards to renewable energy in the Masters in Energy course, is these kind of questions. You know, as an engineer, as an electrical engineer, my students are very technical, but I want them also to think a bit more holistic about power and about energy. Because as an engineer, you're going to be working in communities one day. You're going to be starting your own companies. You're going to work in companies. And you're not only just going to be required to work on a technology, and this is all you see, this, call it this black box that you build, and it gets shipped off. It's people that you're dealing with. Because you're going to deliver this box to somebody, and somebody will use it. But who's that somebody? As an engineer, you need to understand this landscape. Who's this other somebody? So it's people that we're dealing with. All right. Then the other paradigm is the decentralized generation. All right, so this is a new way to think about delivering energy and delivering energy to community, delivering energy to you and me. And I call this the community empowering model, which is the more newer model. And this is a problem model largely across the globe. All right? And we just bring that back home to South Africa, is that Eskom doesn't like this model. They don't like this model. All right. And why? Because it disempowers government to control the masses, really. All right. So it's basically through microgrids. So that the name has changed many times over the last few years, you know, in terms of the capacity of a microgrid. It's sometimes been called nanogrids, picogrids, that manner of thing. But generally, the term microgrids it's just stuck. It doesn't really matter whether that microgrid is grid-tied or standalone. It matters not. It's the form of this decentralized generation that is important, which is this microgrid version. All right. So what this basically means is that your utility, government, local, national, provides then through this decentralized generation model, all right, which means your towns, your communities, they have their own power generation capacity. They have their own renewable solar farms, wind farms. They have their own, call it coal power station. It's no more the national whole country that is dependent on one utility, all right? But it now becomes multiple utilities. And when something goes wrong on one of them, it's not all of us that is affected, as is currently the case. It's a small community, it's a small town, small city that is affected. All right. And this empowers communities, or at least it should empower communities. Because if you're in a municipality, if you're in a town, if you're in a city that is not able to deliver that power to you, you basically can decide to leave. Because you are then voting with your pocket and saying, I'm not going to keep paying you my services, and I'm not going to get anything back for it. In this current model, local governments can say, well, you can't blame us. because it was Eskom. And you know, they run the show. Don't look at us, we're just the middle guy. So this way they can escape responsibility. Under this model, they must take responsibility because that asset of their generation capacity will be owned and run by them. And if they're not able to keep that lights on for you and me, we can say, sorry, I'm leaving, I'm moving to the next town. And that local government will then lose its income, its revenue, by whatever way that it's dealing with it, but it has to then think and say, hey, if we're going to keep wanting to be around, we better start delivering services to these people. Because we cannot blame anybody else anymore. It is only us running the show now. So it's a different way to think, and it really requires you and me, as citizens, to do that thinking change. All right. So yes, the other aspect I also want to touch on here is capacity factor. But capacity factor basically means, from a generation standpoint, as an example, if you've got a solar panel that's 300 watts, all right, over a year, how often is that 300 watts produced? That's basically a capacity factor. All right, so for any power station, for any power generation plant, what is its capacity factor? And the issue then becomes with regards to renewables that capacity factor is a problem. All right, because of the variability in that resource, the variability in the sun shining, all right, in the wind blowing, and so forth. So it basically means that for large parts of a year, if we just stretch it out over a time span of a year, there's large periods there that if you're just depending on solar and wind as an example, you are going to be in trouble. All right, if you don't have some energy storage capacity linked to that. And then obviously, with regards to siting, where you can place these power stations, you can only really place if you are going to be placing your renewable power stations, as an example, you have to place this close to the resource that exists. All right? If the wind resource in your particular location, your particular GPS location or area is very low, it makes very little financial sense to install wind turbines there. All right, so you basically then have to install your renewable power plant at the point of the resource. If the sun is not, if it's the sun, the solar insolation level is not very high in this particular area, it doesn't make financial sense to install a solar farm there. All right, so all of these kind of aspects comes into play when we start looking at siting issues. The other aspect is also power densities. I'm just trying to make a distinction now between renewables and fossil fuel. All right, so in terms of power densities, what does this basically mean? Just the power flow in a unit area. Just an example over here with regards to power densities. Not all fuel sources are created equal. This is just how it is. So your fossil fuels, you'll see they have very high power densities. And this basically means that over a certain area, you can get out of that area a large amount of power. As opposed to solar, as an example, or renewables, you'll need a much larger area, all right, in order for all of the solar panels to fit on, in order to compete with that same surface area for a fossil fuel plant. So it's that kind of thinking that we must just keep in mind, all right, because we're not all of this being so romantic about renewables. We have to be realistic as well. All right. Then, as was mentioned with regards to hydrogen economy, this is a new buzzword, all right, and South Africa is really, or is poised to be a big market player just because we own the bulk of the platinum reserves. Previously, we've exported that platinum, all right? It was used in catalytic converters for the auto industry, but now with fuel cells become prevalent and the whole notion of hydrogen economy, it's becoming a very important player in that regard. So this means South Africa should really be at the forefront of dictating this approach to this hydrogen economy, which we are at some level and some other levels not so much. All right, let me just explain that and unpack that. So in terms of a sustainable energy future, this hydrogen economy is a big player with regards to the government, all right, through Hydrogen South Africa or HISA. It's recognized, the government has recognized that it's got the potential to become this big player. But how and what do we do in order to take advantage of this? All right, so previously, in terms of hydrogen production, it was really done via what is known as gray hydrogen, which is hydrogen produced from fossil fuels. There's something now called blue hydrogen, which is hydrogen produced by natural gas. All right, the whole natural gas thing has become like, if you start hearing the talk about natural gas, it is become, you know, Western economies have begun to use gas as an intermediary between renewables and coal and oil. And it's almost selling gas as saying, oh, well, yes, it might be fossil fuel, but it's not as bad as coal and oil. It's not as dirty, you know. Okay, it's not as good and clean as renewables. But gas, you know, it's very good, huh? It's very good. It's practically clean, huh? Practically. So you must just try and understand and hear the language that is being talked, all right? And it's basically the fact that gas reserves are being found globally on a large scale. Off the south coast of South Africa, gas has recently been exploited, all right, been found, and there's exploitation plans for it. And it's the same picture globally. And this is why gas, the whole rhetoric around gas is changing. All right. Nevertheless, and there's all move then to green hydrogen, which is then hydrogen produced by renewables. All right. For me, from my side, I would say that a more sustainable future, all right, would be a diversity of supply. It can only make sense in the short term, if short term is 50 to 100 years, all right, where we begin to wean ourselves off our coal generation and eventually begin to introduce more and more renewables and energy storage onto the grid. All right, but it is this diversity of supply that gives you this flexibility, and it also gives you this energy security, because you are not dependent on any one technology. Right now, our economy is largely dependent on coal. If something happens at Medupi, if something happens at Letabo or Arno Power Station, you and me, we feel it, because we are so dependent. 80% of our economy is run on coal. If anything happens there, you and me feel it, the lights go out. A diversity of supply says that no one technology dictates the power for all of us. So if any one of them fails, the lights still stay on, because we are then moving on. We're shifting our focus to the other generation within that supply. All right. And then it's also quite interesting that the diversity of South Africa is really also of its population. This is also our greatest strength, our diversity. All right, so it's got very interesting dynamics built into it there. All right, so it would be that mix of fossil fuels and renewables on our grid that will give us that energy security and give us that flexibility. All right. We are basically trying to use our local resource. We've got very good renewable resources, but we also have very good coal and gas resource. Are we just supposed to close our minds to the fossil fuel because it is being termed by others as being dirty? All right? And they themselves use that same technology to grow their economies to be this dominant economies of the day, but won't want others to try that same path, all right? So it becomes that kind of aspect. Then the other thing I just want to touch on is bioenergy. All right, so bioenergy by and large is not being really tapped into, but I see this for sub-Saharan Africa with the resource of organic material that we have across the subcontinent. That bioenergy, which is basically just using the waste from our farming activities, from our livestock activities, all right, to use the gas that we can generate there through anaerobic digestion, all right, to get to biogas. And this is a resource which, in terms of clean cooking, is a very good resource, all right. Then the other aspect is just when we start hearing people talking about, you know, the plans, future plans and policies and so forth, we must always be mindful of which future are we buying into. Is it future which is coming from our own making, or is it something which is coming from outside that is being imposed upon us as if there is no other alternative? So it's important for us as a country to own this future and not allow a dictate. Because as an example, if I'm just talking about the green hydrogen and hydrogen economy, for a large part, that has been pushed by Germany. Germany had great plans. It put together a draft policy, which it then sold to the government. All right, so I'm just trying to say that we must always be mindful of whenever we hear about plans and about this is the future and this is the only way, that is this our future? Have we bought into it, or is it something from external that is being pushed onto us? All right, then the other aspect is really just, before I close, do we see ourselves becoming more and more consumers, or do we see ourselves as being what is termed as prosumers, which is producers as well as consumers? All right, we just take a look at this graph over here. So this is the energy per capita across a few countries. So it gives you an idea there of the energy absorbing countries per capita, per person. All right, and you can see an example, Canada, US. Each person in that country is using at least 5 times as much electricity than any one of us in South Africa. So the question then is, do we build more and more power stations to keep up with this insatiable demand? Do we aspire to be like these Western economies that they have an ever insatiable demand because you're just going to keep on building more and more power stations into perpetuity? Or do you think the other way of, instead of me just taking from the grid, should I also not be contributing to that grid? Be a producer. I can be a consumer, obviously, but if I'm just going to be taking from the grid as consuming, obviously you can see that becomes a problem. So do I want to become a producer as well and contribute to that grid? All right. And then lastly, just in terms of our own energies, whether it's political energies, whether it's electrical energy, what will we use? How will we use this energy of ours? Where will we put this greatest emphasis? I thank you.
Thank you, Dr. Marco Donis. So Marco is the head of department of electrical, electronic, and computer engineering, and he's also very active in research. And what Marco has given us is a very in-depth and very broad understanding, I think, of not just what we can do as individuals within society to reduce our consumption and to not just that, like Rida says, make our own energy, but also looking at the bigger picture. I think that we must realize that change is not going to happen immediately. There's going to be lots of capacity building, education, conscientizing, and I'm so glad that you provided us with all those facts and figures so that we can understand also globally how what happens in the world impacts on us in Africa and South Africa. Your comment about power to the people, I think if I could add bringing power to the people versus harnessing the power of the people to create energy. And it's going to start with us, as I said, and that change may be slow, but I think we are ready for that at CPUT. And there's even a task team that has been formed by Dr. Powell to look at how can we do it at our university, because we're always looking outwardly. Let's look inwardly as a university and take in what has been said by the keynote and by Dr. Donis. So I met a very, very special person at our student leadership camp. And Annalisa, are you here? Annalisa Fritzter, please come forward. Her bio is not in the program. So just to mention while she's coming up, she's passionate. She is a passionate and dedicated, you can come up, Annalisa, chemical engineering student who possesses a deep commitment to creating a positive impact through your academic pursuits and extracurricular commitments. As an advocate for inclusivity, she's an active member of both the debate club. She gave us a run for our money at the camp, I must tell you, and the Queer Unicorns group on campus, championing the rights and visibility of queer individuals. She's driven by a strong desire to contribute towards a sustainable future, and she has chosen to align her academic and personal interests with the United Nations Sustainable Development Goals. All the students, there were 74 of them at the leadership camp. All their project activities had to be aligned towards the Sustainable Development Goals, so I'm glad that you put that in your bio, Annalisa. And she's focused on working towards the goal of affordable and clean energy, recognizing the crucial role that accessible and clean energy plays in addressing global environmental concerns. So she devotes her efforts to finding innovative solutions and promoting sustainable energy practices. So that's Annalisa, but you're not coming here to do a demonstration. She's going to be delivering a poem. So over to you.
Thank you, ma'am. Ladies and gentlemen, fasten your seatbelts and take a trip with me, a journey into the future. This is your future. As you can see, the lights are off. This is a future consumed by darkness, a future that awaits us, a future that awaits our future generation, a future that will be consumed by ultimate darkness, an increase in heat, droughts, floods, wildfires, and a rise in the sea levels, the slow death of planet Earth. Dear future generation, we used to possess this remarkable cellular device called Androids, iPhones, your laptops, your tablets, and etc. And these devices introduce us into wonderful applications such as your TikToks, your YouTubes, your WhatsApps. Believe it or not, the sky used to be blue. We had these big, beautiful trees that grew plants, blossoming plants and fruits and vegetables that fed our society. We had rainforests. We had wonderful creatures that walked this planet. Your lions, your polar bears, your giraffes, your elephants, etc. But because we failed to fight against the abuse of natural resources. We failed to invest in those that had the solutions to fix this very crisis we are in. I speak of the students and the researchers that developed the solutions, the prototypes, the journals. They invested their time into this. I speak of the advocates of our planet. I speak of those who protect Mother Nature. The companies that swiftly transition into renewable energy, working towards a better planet. We failed. We failed as a country. We failed as a nation. You and I failed our future. We failed our generation. We failed to take responsibility. Our reluctance to embrace sustainable alternatives prevented us from moving forward as a country, as a nation, as a society. Instead, it took us 100 steps back into the past. Us as a society and as a nation and as a country, instead of then moving forward, we moved back. Why? To the future generation, let me explain. We were so consumed by our own pursuits to take action. We listened to those that made excuses for inaction. We were the generation that postponed until it was too late. Like Prince E.R. once said, we put profit over people. We put greed over need. We put the rule of gold over the golden rule. We use nature as a credit card without a limit. Please forgive us for letting you down, future generation, for not prioritizing the needs of our planet. No, wait, I am not apologizing for what can be fixed, for what you and I can fix. Let us be the nation, let us be the country, let us be the society that puts people over profit, that puts need over greed, that puts the golden rule over the rule of gold. The students took the first step, the researchers took the first step in developing wonderful prototypes for us to use to save planet Earth. Let us invest in them. Let us invest in their ideas. Let us advocate for their ideas. Let us put bridges from students to investors. Let us put bridges for investors and researchers. Let us form bridges with society and government. Let us join as a nation. Let us stand together to fight this crisis. Let us eradicate this darkness. This will not be our future, not on my watch, not on my generation's watch. Not while we have researchers and students that sit amongst us that produced and formed and invested their time into those projects and prototypes you're about to see in the sports hall. The time to play small and think small has long gone. It is time to think big and play big. We can't save planet Earth by playing by the rules and the norms of society. The rules have to be broken. The norms have to be broken. New norms have to be formed. New rules have to be formed. And that responsibility lies within you, lies within me, lies within our communities and societies. It is time for us to stand up, Don't be the generation that folds their arms and say, I'll see it when I get there. We are here to form legacies. Our LGBTQ community, how will you see your future if you don't join with us scientists? Just because you don't know anything about scientists, advocate for it. You don't have the right to say you don't know when you have an access to a device that has that power, that has all the information you need. You have the ability to read. We have the ability to think. Because 30 years or 100 years from now, South Africa will not be able to purchase coals from these other countries that we buy them from. And as the previous speaker said, we have the resources within our country, but we fail to see that. We are so delusionalized by the American vision. How about we make the African vision? Let us be the super country. Let us be the superpower. No more the delusion of the European countries. It is our time to shine as a country and as a nation, and I believe in that, and I stand for it. And equal rights for women and the males. Where will that be in the next 100 years? Where will the grade 6, the primary school kids, what will they see? Will they see these wonderful devices? No, because we will not have electricity. We will be sitting in this darkness. Will they see the beautiful creatures that we now have, or will they be extinct? Let me answer that for you. They will be extinct. So what are you going to do? And what are we going to do as a nation to show the rest of the world who are we? Because we are Africans, and we have the resources to show them how powerful we are. Thank you.
I have nothing more to add, Annalisa, except to say thank you for energizing us. We are marching with you. We are. Thank you, Annalisa. We have our last speaker talking on agriculture, advancing millets for a healthy diet, the difficult conversation, which I mentioned earlier on. And we're going to call on Mr. Ndumiso, Mrs. Seleli, who is the manager of the Agri-Food Technology Station, the Faculty of Applied Science. I can't see. Yeah, you can do that. I see the lights went on. Thank you, Dr. Marco. That it?
Yes.
Thank you so much.
Good morning, colleagues, visitors and students. Thank you for this opportunity. Thanks to the VC for hosting this wonderful symposium, and thanks to Jackie for inviting me. And thanks to my Dean, Prof. Kyoko, for giving me this opportunity as well to come and present to you. I was asked to give a topic on advancing millets for a healthy diet. A bit about myself. I'm the manager at Agri-Food Technology Station. We are one of the 18 stations around the country that are funded by TIA. Some of you don't know TIA is called Technology Innovation Agency, which is under the Department Department of Science and Innovation. We are funded, we are in different sectors. In fact, at CPUT, we have 3 of these stations in engineering, textile, and the one in food. So the background about the station, just before I can go to the topic, I just want to give a background so that people can be aware of the station and what we do, and what wonderful work we can offer to the young people, the opportunities that are available for them. So the Agri-Food Station was founded around 2004. Those are just topics I will be talking about. The background of station, the history of the millets, the benefits of obviously, and the advantages of that. And also I'll give some examples of products that as a station have worked on, which are related to some grains. So as I mentioned earlier, the station was formed around 2004, and they were funded by TIA, as I mentioned earlier. We are based at the Department of Food Science and Innovation. Food Science and Technology here in Belleville. We are governed by the policies of university. As I mentioned, we are hosted in one of the stations around the country. Some of you might not be aware of the beautiful department we have. We have a nice pilot plant with some of the facilities that are world class, that everyone can utilize. We have laboratories as well, and we also use these to provide to our clients. Not gonna go down, bore you down with more of what we do, but just the overview is that we do product and process development. We do research, testing and analysis. We do a lot of these for postgraduate students, so they have got that access to use the facility, and then we assist them. We do physical properties, shelf life studies. We also assist with upscaling of processes and the use of the facility for processing. Quickly on this topic of millets, when I was doing a big background research on this, I found this grain very special grain. It's widely grown around the world, and it's very resilient. It grows in extreme weather conditions, and you find it mostly in Africa, East Asia, South Asia. Africa produces about 97% of the millet. The crop is favored due to its productivity and the short growing season under dry and high temperature conditions. So this is one of the old grains. It's been consumed by humans for about 7,000 years. It is a pivotal role. It plays a pivotal role in the rise of multi-crop agriculture and settled farming societies. So the mostly grown millet is pearl millet. I'll show you some examples of products that we've worked on as well on the pearl millet. It is noted that the pearl millet in the SADC region is the 3rd most important cereal grain in terms of production area, with Namibia and Tanzania each accounting for about 27%. It's mainly grown on a subsistence level in hot regions with irregular rainfall patterns of rural southern Africa. As I mentioned earlier on, it's very resilient grain. I've just shown you the picture, some of the types of millet grains, which the peanut millet is one of those that are shown in the slide there. This is just the plant that shows the millet, and on your right hand side you see there's a ripe head of a proso millet. There's more of these types of millets around the world, as shown in that slide. After processing, you find that when you do the processing from the grain, you get the flours. The slide shows some different flours which can be applied to make various products. So the importance of this millet grain is that they are gluten-free. Also, they're easy to digest. You know that there's this growing market now, or growing community of people that they use gluten-free products, so which fits in very well with what's happening now. They have low GI. So they also contain, they have six times more fiber than the wheat, making ideal for weight loss. They also been discovered that they have heaped with essential nutrients and antioxidants. Millets also contain antioxidants that reduce cholesterol levels and hence reduce the risk for heart diseases. So it's also been discovered that they're very useful in diabetes. So in place of refined wheat or white rice, it is a great choice. So some of the benefits of different millets. The pearl millet is understood to be good for insomnia and also type 2 diabetes. The kodo millet is good for diabetics as well. Foxtail millet, good for thyroid. Bainad millet, good for weight loss. Little millet has got an indispensable good fat. So comparing this to wheat, nutritionally, as I mentioned earlier on, you find that the source of fiber, protein, and vitamins, mostly B complex vitamins, as well as minerals. For digestibility, it's easy to digest. It also has a low GI. It's a versatile grain. It can be used in cooking as a side dish. It can be added to soups, stews. Can be ground into flour for baking. It's a very versatile grain as well. And then environmentally, as I mentioned earlier on, it's considered to be more sustainable crop compared to wheat. It requires less water, fewer pesticides to grow, making it environmentally friendly choice. Another advantages of it is a culinary diversity. I just shown some slides here. One of the products that you will find on the shelves if you go to the shops, this Nature's Choice. This is normally find it at places like Tiscam pharmacies. And then on the right-hand side, you see the awakoshi. It's a canned puff millet confection. It's mostly consumed in Japan. As I mentioned earlier on, the flour from the millet. Millet flour is light in texture and can be used in many products, including pancakes, bread, muffins, and cakes. And it's just reinforcing that importance of this grain. As I was shopping around the other day, I saw this, that Woolworths is also stocking a lot of these grains. There's this sorghum grain. In fact, in one of the, the label there, they mentioned it's an ancient grain, which is very versatile. So this is, for example, it's about 32 rand per 500 grams of that grain. So you'll see that if you go to the shelves now, there's a lot of these reintroducing these type of grains. So which is very good for people who are gluten intolerant. So the next slide will talk about some of the projects we've done as agri-food related to some of the grains. We have worked with this client is based in Namibia, where we assisted her to develop a fermented beverage called oshikundu. You remember in my previous slides I mentioned that this millet is very, Namibia accounts for a very high production of the grain. So she came to Cape Town and then we assisted to develop this product. Which on the left-hand side you can see the formulations we did. We did about 6 formulations. You can reconstitute and make that beverage. So this is some of the label of the products. You can see that the advantages of the pearl millet. It ties into what I mentioned earlier on about its application. So this is the packaging of the product. It's a finalized product. It's already been sold in Namibia. In fact, this picture that we took, she was here early this year to complete the project, which we started with it about 2 years ago. So some of the grains, as I mentioned earlier on, this one is the sorghum. It's a sorghum-based biscuit. This is another client that we did a value addition on this product. Sorghum biscuits, we made 3 variants of this product. She's based in Johannesburg, and then she also did come here to learn the process of making the product. But it was an idea that she had, and then we sort of assisted her in developing the product and also getting it to packaging. So the reason I'm also showing some of this example is that this is an opportunity for some of the students within the institution that they can come and use the facility if they've got ideas of products they want to develop. We can assist in that because of the funding that we get is for that we expand our services to students, to communities, to entrepreneurs. So you find that some of the clients that we have are outside of the province. So we want to increase our visibility even within the institution, also within the Western Cape. And then this one is also a sorghum-based drink, yogi sorghum drink. This is also a finish as well. We're already doing packaging for the product, so it's foolproof. We've done the testing, we've done the shelf life of the product, so it's only now about the packaging that we're finalizing. Another example is another client that is based in Johannesburg. Oats grain, we did an oat milk. This is a young man, he's only 21. He's also coming from Johannesburg. So he's also selling this product. We started with him assisting to develop the product, the processing, up to getting the product. And then we also assisted him with the testing. And then we also assisted him with us sometimes outsourcing some of the analysis if we don't have the capabilities. We subsidize those costs through the funding we have. So with those few examples, this shows that the food science and technology is very important in terms of the future, in keeping us healthy and making sure that we strive as young people, as the community, so that we are able to think clearly and apply our minds in what my previous speakers have mentioned about, being creative in terms of creating energy for our country. So, a good health keeps the mind healthy, so the health is very important in all of this. So all these products is the products that we should be trying so that we alleviate all the ailments that as people we have. On that note, I would like to thank you for listening. These are my details. And then once again, thanks for the opportunity. And I'm hoping that from this time, you'll contact me and then we have chats. And I've got some references there from some of the slides I showed. And thanks very much.
It's at events like these, I think, where we get to know more and more about our own people at CPUT and what they are doing. Sometimes we walk past these buildings and we have no idea what is happening inside. That was quite impressive, and especially to the students, I hope you notice how important the packaging and branding is to the product that is being sold. So you, as a product of CPUT, you need to package yourself and brand yourself well, so that when you are out there, you are truly showing what you can do. The practical examples that you gave us, I think, really resonates with people. As you know, in South Africa, we take our food very, very seriously. We had quite a debate about what to offer you to eat. We decided, in celebration of National Science Week and with the sub-theme of millets and alternative grains, that many of the food that you will eat today is made of the alternative grains. And there are 1 or 2 millet items that you can savor, and thereby reducing the gas of the cows, Dr. Marco. So now I'm going to... We're getting to a really special time in our program. I want to call on Dr. Frikkie George. He was also with us on the roadshow. So I think we arrived was it yesterday or the day before? And if I can call him to come up, he's the STEM support lead for Fundani Ched at CPUT. He also is volunteers his time on a Saturday to teach our second chance learners at CPUT. So I'm also going to ask Dr. and Professor Chris Nhlapo, our Vice-Chancellor, to come up as well. And for this part of the program, we are going to be awarding those students who entered the STEM competition yesterday. There were quite a lot of judges, I believe. And I apologize, I was at a funeral. So I believe it went quite well. So please come up, Professor. I'm going to hand over now to the two of you. Just call them all to come up.
Okay, thank you, MC. And can I ask all those exhibitors of the competition just to ascend the stage, come to the front? All of the candidates. And while they're making their way to the stage, just for your for the information of the audience, yesterday we had actually our very first CPUT National Science Week STEM Expo, an expo which covered all the departments at CPUT. So we had entries. We had about 102 entries in total, initial entries, which we had to short list to about 30, and then further reduce it to about 20. Okay, I see this. David isn't. Okay, so each one of the exhibitors will receive a certificate of participation, and so none of them know who the winners are of the competition, of the expo competition. The judges, we actually did, and I must once again say thank you to the judges who were able to see their way out to sit until late, deliberated. We deliberated up until almost 5 o'clock, and we had to face the traffic jam afterwards. But it was work well done. So eventually, we agreed upon seven winners, and I will just quickly ask them to, I'll call them from the bottom upwards. So the 7th place, or the 6th place, which is actually occupied by 2 winners, it was Exhibitor 1 and Exhibitor 22. Can they maybe just step forward? Exhibitor 1, Moral, designed or presented a dual motor generator, and Exhibitor 22 presented a biofuel for the new age. Sound interesting? So afterwards you will be able to view the exhibits. So in terms of the prizes, the winners are receiving a cash voucher which they can redeem at Venskijk, and then also a tracksuit, and then a certificate, of course. And then we move up in terms of the places. So in the 5th position, we have Exhibitor 18, who exhibited a prototype generating energy within a park, playing park. So, and it's a pair, Emmanuel and Buko. In the fifth position, we have Exhibitor 28, Joshua. He demonstrated an idea, a concept about how to deal with cyber attacks on sea, at sea. In the 3rd position, we have Exhibitor 20, Dominic, And his prototype is about an lead iron battery inverter. The second position we have exhibitor 30 was demonstrating futuristic energy. And then the overall winner of the this year's Expo competition was exhibitor 29, and he and and wait for it. He displayed a prototype for how to address load shedding. His prototype is displaying how to make use of a car wind turbine. And the rest of the competitors, we have your certificates of participation, and then maybe we can just have one big group photo. Check if it's
Can you ask the deans and the deans to come up and the DVC for the last photo?
And then can we maybe humbly ask the deans of these students, because all of them are students of CPUT, if they are deans and maybe lecturers in the hall, if they can maybe also join us for the group photo, please do that. And of course, the DVC of Learning and Teaching, Prof. Balkram.
Okay. David, you see I'm delegating.
Do we have school English also here or not?
Most of them cancelled. But we will go to the schools after this. Yes, unfortunately.
No worry. It was good. I'll just wait for Professor Hishwame. I have your ROP meeting.
Oh, okay. Now you can't miss that. But thank you very much. Very shortly, we're going to have to excuse some of our members, our executive management members, and our Vice-Chancellor and the Deputy Vice-Chancellor. They have to attend another engagement. But we so appreciate that you attended and supported. We can feel the strength behind us. Otherwise, we would not be able to do what we do. So we are running a little bit late, but I think we will catch up very soon because after the formal program, we will ask you to go over to the major sports hall where all the students will be exhibiting as well as our external partners. Calvin Maseko and I will then be responsible for the latter part of the program. Calvin Maseko is from the Department of Advancement, and again he's one of our pillars in community engagement, always supporting and driving us to achieve greater heights and always looking for funding opportunities for us. So Calvin, can you please stand so that everyone can see my partner for the rest of the program? So, as I mentioned, next door there will be these exhibitions, and we're going to ask reflective thinking about what you've heard and seen and felt also this morning. What some of your ideas are, what can you advise us? You know that reflection plus action equals learning, according to John Dewey. We use that a lot in community engagement. So we can't just listen. We now need to think about things in a deeper way. So we have a World Cafe also next door. So there are many, many round tables. You can move between the tables. Each table will have a question relating to the symposium. And when you sit down and you interact with the students there, we will be taking those comments and putting it up. So that you will all receive a summary of today's proceedings. So we must ask you to engage, not just think, but put to paper. That's what research is about. Not to dream only, but to read and to put it down onto paper. So we also have some external partners exhibiting. I think, David, the Green Cape is going to do a presentation over there. So we will need to hurry over after this. But we're going to be ending with, in this auditorium, we're going to be ending again with Annalisa. Is she here? Oh, sorry, I'm sorry. I've lost my specs. I've got it now. Can you see? Reading is so important. Okay, so before we move on to the last item, I'm going to hand over to Prof. Driekie Huyswemer, the Executive Director from the Office of the Vice-Chancellor. And your passion for STEM is also what really motivates us in our center. And also, you're always there to support us. So I think it's only correct that you will be the one closing the session with some of your words of wisdom. So please come up. Thank you.
Just get my speech out here. Thank you so much, Jackie. And once again, good morning, Moweni, bonke bantu namhlanje. It's indeed for me a wonderful privilege to say a few words of motivation to all of you here. Obviously, our students are the most important people here today because you are going to be the next generation of innovators, people that are going to discover things that is going to create a better world, a better South Africa, a better Western Cape, and a better society. I think during this week, because it was National Science Week, many of us, and not only here but also across the country, came together to celebrate the pursuit of knowledge, and more specifically the pursuit of STEM-related teaching, learning, and research. And it's basically because of this pursuit for knowledge, the power of curiosity, and knowing that STEM has a great impact on our world and to improve our lives and to make it better. So today for me, and I think for all of us at CPUT, since we've started this program, it is indeed a momentous occasion with all of you here, embarking what I hope will be a continuous journey of inspiration and motivation. Encouraging all our students here, but also, and very unfortunately, the learners from schools that were invited but cannot be here today, that we will continue to motivate them to become really involved in STEM subjects and consider careers in the STEM disciplines. Because we know that by doing so, they will contribute towards the future and will have a positive impact on all our communities. Students, as already mentioned here this morning, in this rapidly evolving world where technology drives progress and innovation, I think it's really essential that we recognize the immense potential that lies within the STEM fields. Science, technology, engineering, and maths are the pillars that have propelled humanity forward, revolutionizing healthcare, communication, transport, and so much more. And it is exactly from this, the discovery of life-saving medicines, to the exploration of outer space, STEM has been the driving force behind human advancement. So students, myself and CPUT would like to urge you to keep on embracing the exciting path of STEM and be part of the change that will indeed shape our tomorrows. Let your passion, and that is what we've seen here today, and also from our own academic staff presenting their research, let that passion ignite your journey towards a profession that not only rewards you with endless possibilities, but also always allow you to make a real difference in the world. Because this is why we are here. That's why we exist, is to make the world a better place, not to live for ourselves through the research and our own interests. So if we look back in history, we see that every breakthrough in the STEM fields has been driven by individuals who dared to dream, who imagined something different, something new, something else, and who believed in their abilities to solve problems and who relentlessly pursued their goals. However, they did not only dream or imagine, they worked extremely hard and never gave up in their pursuit of knowledge. To make breakthroughs, to advance science, to become a world-class researcher, it is hard work and dedication. And I think, and I hope that the lecturers here and all your other lecturers have already inspired you to consider an academic career. I thought on a day like today, it's maybe just good to go and celebrate the lives of a few profound researchers, and specifically black scientists and mathematicians. I have deliberately decided to showcase some women because there is this perception that women are not necessarily so good in science, but if you see what they have been doing, you will be so surprised. And also that to do maths and to be brilliant scientists are only meant for a few very smart, small grouping of people, and we must demystify all those myths about science and and maths. The first person I just quickly want to highlight, and maybe if you can read about her, I think it will really, really inspire you, is the life of Katherine Johnson's. Her passion for maths began at a very early age, and at the age of 13, she went to university at the age of 13. And after receiving her doctorate, she joined the National Advisory Committee for Aeronautics West Area Computing Group. This was a group of human computational experts called computers before the advent of modern mechanical computers, composed entirely of black women. And did you know that she was instrumental in the success of the first Apollo? Without her mathematical calculations, they could not get it right. So, in 1962, she provided the orbital entry and launch window calculations that enabled John Glenn's orbit around the Earth. She also provided calculations that coordinated the Apollo moon landing, and she received the President Medal of Freedom in 2015, and her work was profiled in the movie Hidden Figures, and that's indeed a wonderful movie to watch. She died in 2020. I think she was close to 100 when she died. So then there is Gladys West, born and raised in Virginia in the US. She leveraged her mathematical and programming expertise to invent an accurate model of the Earth, which was used as the foundation for the creation of what we know today as GPS. So this woman, way back, she already knew about GPS as we know it today, global positioning systems. How do you men feel? Oh. Women have a sense of direction. She was the second black woman ever to be employed by the Naval Service Warfare Center Dahlgren Division and was inducted into United States Air Force Hall of Fame, one of the highest honors awarded by the Air Force. What a woman. Then, known as a human computer, now she worked with Katherine Johnson at NASA. Dorothy Vaughan, she's also part of the movie Hidden Figures, by the way, was part of a team that did mathematical calculations to help launch satellites. We're not the first to have launched satellites. It was actually quite an incredible woman who way back also had the foresight. So the group used maths to help engineers figure out how wind and gravity affects our aircraft. Who says a woman cannot do that? Yes, we can. So, and then this is also very interesting. Before her 30th birthday, Mae Jemison had received two before the age of 30, 2 undergraduate degrees and a medical degree, served 2 years as a Peace Corps medical officer in West Africa, and was selected to join the National Aeronautics and Space Administration's astronaut training program. 8-day space flight aboard the Space Shuttle Endeavour in 1992, maybe some of the students were not born then, established Jemison as the United States' first female African-American space traveler. And obviously then we have people in our country like Charlotte Maxeke. We know about her history in the struggle for freedom of this country, but she was indeed the first black woman to get a degree in a Bachelor of Science degree. And she always fought for that and stood for that women should not only be accepting that, you know, they have to go for softer options, but they can really be very successful in science and technology. So I can continue with numerous examples. Why do we need you, students sitting here today, to become our future generation of scientists and innovators? The reason is quite simple. It is through STEM research that we explore the unknown, challenge existing knowledge, and unlock the secrets of the universe. And I want to believe there are so many more secrets that we still have to discover and learn from. Research fuels our curiosity, pushing the boundaries of what we know and propelling us towards new horizons. Each experiment, each discovery, and each innovation brings us one step closer to a brighter future, as pursuing a career in STEM is not just about achieving personal goals. And it is for this very reason that our Vice-Chancellor did not only dream about a very special project for STEM at CPUT. He really stood up and executed on the mandate to make sure that STEM, at least in our province, will also become accessible to schools. And for that reason, we have started to launch the VC's prestigious school STEM project. And we have already, where's Mr. Maseko? How many money have we, received from donors? Close to 10, 12 million rand. And I think our dream is not far, that very soon we will see CPUT Center for STEM Education and Research, and hopefully with the first research chair. Our legacy is becoming bigger. You've heard this morning, Ms. Gibbers talked about Beaufort West. Our footprint is on the West Coast. It's in Mossel Bay George area. It's even in Kofimbaba in the Eastern Cape, where we have a very, very special project going on. So today, as we celebrate STEM, let us acknowledge the unsung heroes who toil tirelessly in laboratories. The VC said he actually lived and stayed in his laboratory. I don't know whether he had a bed there, VC, but that's how tough science can be. You can't leave your experiments. So, and especially for those and our own academics here who work tirelessly towards unraveling the mysteries of our world. Remember, the road to success and a successful career in STEM-related fields may be filled with challenges, but it is through these challenges, I believe, that we grow, learn, and evolve. Embrace them, for they are the stepping stones towards greatness. Believe in yourself, for you possess the power to change the world. And our student earlier this morning, she said it so well. It's up to you, it's up to us. We cannot wait for others to dictate that what should be happening. So may your journey towards a STEM career and qualification be filled with endless possibilities and boundless success. May many of you leave a STEM legacy, footprints across our beloved African continent and elsewhere. We at CPUT watch your future with great curiosity and anticipation. I would like to close by quoting a powerful statement of Maya Angelou. If you are going to live, and believe me, you are all still living, you're all alive, leave a legacy. And here's the most important part. Make a mark on the world that cannot be erased. My wish is that your legacies will never be erased. All of the best for your research and your future. Thank you.
I didn't think that I could become more inspired, but I think it is happening. So we have one more item before we move over to the other side. And I know that you have to leave, VC, and your entourage. Please travel safely. I may also suggest that if you want any pics to be taken, we would like one with the, are you the only dean in the house? With the dean and the directors and our team who work so hard. You will see that at the bottom of the, what page is this? Page 2. You will see the team at the bottom who made all this possible, many evenings, late nights, and so on. So we will do a proper thanks on the other side when Calvin and I start the program. But for now, let's get some more inspiration going. We're going to call our award winner again to inspire us some more. And she'll be doing, Jolene will be doing another song for us. I must ask you, let Jolene finish and then we can depart. You closing, Jolene? Wow, I really miss the entertainment industry. I almost did another curtsy. Um, thank you so much. I think both song choices are so relevant, and yeah, we're all interconnected and we are all joined together by our humanity. So let us work together. Let us go and support our students over there and all our partners. There's an exhibition waiting for you. Stay as long as you like, and we will be having lunch after that. And Calvin and I will be doing our program. So please proceed over there and enjoy it. Ask questions, make comments, so that we can, give you some feedback. Thank you, everyone.